everyone, today we are going to be taking notes on solutions to linear equations with one variable. You should have received this document the day that you took your quiz, and so we are just going to fill it out and solve some equations and understand the difference between one solution, infinite solutions, and no solution. So, the solution of an equation is the value or values of the variable that make the equation a true statement. We've been practicing this with our angles when we plug our variable back into our expression to make sure both sides are equal to each other when we did that with our vertical angles. So equations in one variable can have one solution, infinite solutions, or no solution. So we have three types. We have one solution, infinite solution, or no solution. So the reasoning, what the type of solution means. So if there's one solution, there's only one value that can make the equation true. And when we say true, we mean balanced. There's only one value that can make the equation balanced. One value means that there's only a number. We don't know what that number is, and we'll have to find it, but there's only a number that can keep them balanced. Infinite solutions is when all values will make the equation true, or again, true means balanced. Okay, and all values means every number. So decimals, fractions, whole numbers, positives, negatives, every number will make it balanced. And you're thinking, when would that happen? We haven't learned those types of equations yet, but we're going to. The last type is no solution, and no solution is that there is no value or no number that will make the equation true, and again, true means balance. So there's nothing that we could do to balance that equation. So this one is no number. So we could say that almost like infinite solution and no solution are opposites, in the sense that infinite solution is every number and no solution is no number. But we're going to talk about the conditions in which we have one solution, infinite solution, and no solution. So, in a true solution, it says always, sometimes, or never. So, in a one solution, it's a conditional equation, which means that it only happens sometimes. And when is that sometimes? That sometimes is only true for one number. And then infinite solutions is that it's always true. So an identity equation is always true for any value of x, and it is going to be true every time. For every number. And then a contradiction solution is that it's never true for any value of x. So this is never. Oops. Started going capitalized, but that's okay. It's never true for any value of x. So it's never true for any number. Okay, there's no number that could ever make it true. So now we have three types of equations, and we're going to solve each equation, and we're going to understand that this column is one solution, this column is infinite solution, and this column is no solution. So the first one one solution is 4x plus 6 equals 18 minus 2x. And if I, draw my line here so that I can solve it, the terms on the left are not like terms, and the terms on the right are not like terms. But I do have an x on both sides, and I don't want an x on both sides. So I can either get rid of the 4x or the minus 2x. I'm going to get rid of the minus 2x by adding 2x to each side. I get 6x plus 6 equals 18. And now I'm going to do inverse operations here, and I'm going to solve that. So I'm going to get the x by itself. So I need to get rid of the plus 6. So I minus 6, minus 6, and I get 6x equals 12. And then my last step is to divide by 6 and divide by 6. And I get x equals 2. That was supposed to fit on that line, but it's okay, I have big handwriting. So, x equals 2 is a value that makes this equation true. How do I know? Well, if x is 2, 4 times x, which is 2, plus 6, has to equal 18 minus 2 times x, which is 6. Order of operations, multiplication comes first. That's 8 plus 6, which is 14. Order of operations. 2 times 6 is 12. Oh my goodness, silliness F4. It's not 2 times 6. It's 2 times 2. X is 2. Couldn't figure out why that was wrong. So that's how I knew, because it was going to make 6, not 14. Okay, so 2 times 2 is 4. 18 minus 4 is 14. So it checks out. What that means is that 2 makes this equation balance. So 2 is the only number that makes this equation true. Sorry for that long pause. I had to do some math in my head and figure out why that was wrong. And it was wrong because I had plugged in the wrong number. Okay, the next one is an infinite solution. So I'm going to draw a line on this equation, both sides, and these are not like terms and these are not like terms, but I can minus a 5x from both sides. So I'm going to minus 5x from the left and minus 5x from the right, which leaves me with 15 equals 15. And you're thinking, that's weird. Maybe I should minus 15 from both sides. Well, the big red flag here is that the x's cancel each other out. So there is no variable left. There's only a number. And the question is, does 15 equal 15? If I add 10 to both sides, would they still be equal? If I minus 3 from both sides, would they still be equal? If I times both of them by 2, would they still be equal? And no matter what I do to this equation, 15 is always going to equal 15. It's a true statement, and it's always true. If I wanted to, I could minus 15 from both sides and get 0 equals 0, which is still a true statement. So 15 equals 15. So every number for x will make this equation true. The last one is no solution. What this means is that I couldn't add or subtract or multiply or divide either side to make it equal. So I have 4x on both sides, and so I'm going to minus 4x on the left and minus 4x on the right. That leaves me with 8 equals 3. Does 8 equal 3? What if I added 5? If I added 5, it would be equal. But if I add 5 to the left, I have to add 5 to the right. Okay, what if I subtracted 5? Okay, well, if I subtract 5 from the left, I have to subtract 5 from the right. So no matter what, 8 does not equal 3. So there is no number that will make these two sides equal. All right, so we have 3 different types. We had one solution where we were left with a variable and equaling it a number. That's one solution. The second example, we weren't left with any variable, and we were left with 2 numbers that are equal to each other, which is called an identity equation. And that's true, so that was infinite solutions because every number I could add or subtract would keep it balanced. The third example was no solution because the two numbers did not equal each other, which I noted with this not equal to sign. And no matter what I did to each side, it has to be the same thing. 8 would never equal 3. These two numbers would never equal each other. It leads with a false statement or a contradiction, okay? So here's a hint. So the end result still has a variable. So if we still have a variable, we have to go through all of our steps to find that value. And it has a solution. So in our example, x equals 2, it still had a variable and it still has a solution. With infinite solutions, the variables cancel each other out. And both sides of the equation are equal. In our example, we had 15 equals 15. And the last one is no solution. In no solution, the variables also cancel each other out. So in both of these, the variables cancel each other out. But both sides of the equation are not equal. And our example was 8 does not equal 3. Thank you for watching my notes and be ready to talk about these 3 solution types during your next in building day.